the X RDD system. These are the topics that I would like to discuss today. So I want to give you an overview of the RDD architecture, the types and the classes in the system. I want to show you how you can add event handlers to do logging, and how you can do your own thing, basically create your own RDD, and how you can intercept whatever the RDD is doing. We have added couple of support classes and features so you can monitor what an RDD is doing. Let's go to my Visual Studio, I think. Oh no, let's do this first. Okay, historically, when we started with DBase, all database access was done through commands. And we all remember the use command, go top, etc. Then Clipper came and introduced functions. And Clipper introduced a preprocessor that translates these commands like use and go top into function calls. In Clipper, these were all untyped functions. Well, you probably all remember that Clipper was completely untyped. But for example, so is also FoxPro or XBase also are untyped environment, and they have untyped functions. Most of the DB functions are available also in other dialects like Harbor and XBase++. Visual Objects introduced an extra layer, it's called the VODB function, with type parameters. So these functions are different from the functions in the DB group, not just because of the type parameter, but also because when there's a failure, they don't actually throw exceptions or errors, but they return false. So it is up to you, if you use these functions, to actually decide what to do. And in Visual Objects, the possible error state was stored in the runtime, and in X we're doing the same. So if you have a VODB function call, we are storing the last RDD error in the runtime, in the state, and then you can retrieve that if you want to process the error. In our implementation, this VODB layer is really thin. It actually does nothing else than call some static methods, and these static methods are then dispatched into the RDDs themselves. We'll have a look at that in the future. People coming from VO, most of them have worked with the DB server class, and the DB server class is based on the VODB function. So if you use X# or VO and you use DB server class, you're actually coding against the VODB functions. That means that any error handling inside data access in the DB server class is handled by the class itself. So it catches usually it is a false return value from a call, and then stores the error state in the DB server object out of the runtime state. So these are the separate layers that you can see. In X#, we have actually introduced yet another layer, and that is the CoreDB class, which is located in our X# core assembly. And the difference between VODB and CoreDB is that, well, VODB actually inherits from CoreDB, and the only thing the VODB layer does is add support for usual values. Inside X# core, we don't support usual values. We only have objects when you deal with polymorphic variables like return values from reading a field in a database. And the CoreDB class is basically the worker that selects which RDD object to use for the current work area. And by already mentioning the RDD object, I'm already a bit ahead of myself, because this RDD object is what we'll look into later on in this session. First, let me switch to some source code so you can guys get a quick idea. New share. Yeah. Over here, you can see my Visual Studio, and let me increase the font a bit. The samples I will upload to the website, but the first sample is this is the traditional code. Actually, this is also the code that people coming from FoxPro are used to. They work with this all the time. And this particular sample application is running in the FoxPro dialect, and that's why we also have support for something that's called scan and scan, which is coming from FoxPro, which is basically a do-while loop with some conditions. But the advantage is that you do not have to code the skip in there, it automatically does that. So if you, well, the sample here uses a table that most of you coming from VO will recognize. It is the famous customer DBF with Todd Evans and others. So when I, come on, run the sample, it has to compile first. Let's run it and then look at it in the debugger. Okay, I've already had too many breakpoints. So this is basically what we see. It walks with the do-while loop through the table and shows me the record numbers and some fields. And there's a scan and scan, which says, give me all the customers in the state of California. And it shows that there are 3 customers in this table that are in California. So this is the old-fashioned command stack. Now, like I said, we are using also functions in the system. And just to give you an idea, if you run this command-based code again, the preprocessor has actually converted this into function calls. So if I'm running a debug version of the runtime, and if I step in, you can see that we now are in a DB use area function. So even though I work with commands, the actual work is done in the function. Now, I'll skip a lot of this, but what you will see here is that it actually calls VODB use area, which is the method that starts to open the table. Now, if you go back, if you would go back in here, you could actually see that this then, oh, I can try it again. So the use command goes into the DB use area, which goes into the use area method. And actually, even though I wrote VODB, it is calling a method on CoreDB, which then tries to locate the RDD and do whatever is necessary. Let me go back to the sample. This is what the code would look like if you would code with the DB functions. You will see it's the same idea. And in fact, if you use the commands, this is also what you're using. The commands are just a convenient way to use these functions. Now, what you also can do is use the VODB functions. And in that case, you see that where the DB use function could skip parameters. So here the new and the RDD name are skipped. If you use the VODB function layer, you have to specify all parameters. So you have to specify that you want to open it in a new area with this RDD, with this table name, alias, and these 2 parameters indicate whether you want to open shared or read only. Now, I'm not checking the return value of the VODB use area. That's not a good idea because, like I said, these functions do not throw errors. They basically return false. But that's what you normally would do. If you code against VODB, you will see that it's a bit less convenient than the field get that are used in this one, because over here, you now have to pass in a variable by reference to get the actual value, because the return value of VODB field get is the logic, whether it succeeds or not. So if you would try to read a field that with a name that doesn't exist, or with an ordinal that is larger than the number of fields in the table, U last would still be nil, and the VODB field get would return false. So this layer is there only if you want to code and handle error checking yourself. It is faster because it does less, but if you have to code all the error handling in your own code, you might probably have not much benefit from this layer, because then you will end up with the same error checks that the DB functions have. But we have added that for convenience. So it does do the same as the DB layer, but it's just a bit less code involved. Finally, the last sample in this one uses the DB server that the VO people are used to. And in this case, you instantiate a server object, again with just like the DB use area, with optional parameters. So you don't have to specify shared or read only. You don't have to specify the RDD. It all takes defaults. And in the code itself, you can do field get. A field get is flexible in the server class. You can pass in a string or a symbol or a number, and it's smart enough to figure out which kind of parameter you use and to find the proper field. You will be not surprised that for the server thing, the result is exactly the same because we're reading the same table. Under the hood, the DB server class also calls VODB field get to read the values. But of course, when there's an exception or an error, it'll try to catch that and keep your server in a safe state. So to summarize, traditionally, we have these levels, this command-based, VODB function, DB function, VODB, or server-based. These are the ways that we had in VO to access data. And FoxPro people only have command-based, and Harbor and X have these levels. Now, what are we doing in X Sharp? What is the solution in X Sharp? Okay, let's go back to the slides. In a previous slide, I already mentioned that in the RDD system, we're using object classes. And since different RDDs can have different behavior, we have actually created an interface called RDD, which is basically the required interface for people who want to implement an RDD. And in the X-based environment, you can open more than one table, and these are stored in what Clipper and Visual Objects called work areas. The FoxPro people call it cursors. And we have a class called work areas class that contains the collection of areas. Each area is an object, and this work areas class is a list of basically all the open objects. And each area has a name and a number, and of course, the object itself. And the alternative name that we use for work areas is data session. This is the term that FoxPro uses. And we have designed our runtime so that we can have more than one data session. In fact, if you open a FoxPro table that is linked to a database container, a DBC file, then we will automatically create a second data session in which the DBC file is managed. So it will not occupy a slot in the work areas for the tables. And if you do a close all, it will not close the database because the DBC file is also a FoxPro table. And so it's in its own collection of tables, and that's why you can close all tables without actually touching the database. If you want to close the DBC, you actually have to call a special command or special function that will then switch to the DBC data session and close the table there. Okay, we have several types of classes, and to work with these classes, there's a table in the runtime that basically has a name and class name there. And if you open an area with that name, the runtime finds the class and creates an object based on that name. And we will see in a sample later that you can actually create your own RDD and add that to the list. And then you can access it with the name that you have chosen. So this table that links names with objects is can be changed at runtime by you or by a third party. Come on. Okay, the most important type, like I said, is RDD. This is an interface that has methods and properties, etc. And there is a basic implementation of the RDD, which is the work area class. And the work area class implements certain methods that many RDDs use. You don't have to use the work area class, but it is there for convenience. So if you start your own RDD, you can basically inherit from nothing. So you inherit from object and directly implement RDD, or you can use the work area class and use method in there. And for example, a method in the work area class that is implemented is the DB eval method that basically skips through the rows in your table based on a set of parameters like a condition, a while condition, or a next number of records or a specific record number. This is all handled in there. And if you inherit from work area, you as RDD don't have to implement that. There are also methods that have to do with the macro compiler. These are also handled in the work area class in a way that you can safely use that. I'll cover the macro compiler in combination with RDD a bit later. Apart from the RDD in the work area, there are also several helper classes. In Visual Objects and Clipper, these were structures. We have implemented them as classes, and these classes are there so you can pass, for example, a filter code block and a filter string. Or if you do an order, you can specify the tag name and the file name and the expression and the for condition in one object. And by using these, we do not have to have very long lists of parameters for methods in the RDD system. They can just accept an object of type DB order info or DB open info and fetch the various parameters from these objects. So the interfaces stay fairly clean. Let me open the RDD interface. I should have prepared that. On my screen, you see the definition of X RDD. There's a lot of comments in there. These are used also in the generated documentation. And as you can see, for example, the method DB eval has a DB eval info object, and this DB eval info object contains the for condition, the while condition, etc. Now, we have the normal methods like go top and go bottom. But for example, you will see a skip and a skip filter and a skip raw and a skip scope. As a RDD, you don't have to implement all of these if you inherit from work area, because the work area class has implementations for a skip filter, which, as the name already suggests, will also check the conditions of the filter. And so if you are an RDD writer, you implement skip roll and you inherit from work area, then skip roll basically moves the record pointers one or forward or one backward, or basically depending on the number. If you do that, then the RDD system, the work area class will take care of handling active filters and stuff like that. Okay. There are two classes related to iRDD. When developing the RDD system, we discovered, when we looked basically at the existing RDDs, we discovered that there were several combinations of file formats, index formats, and memo file formats. The most common one are, of course, DBF, NTX, DBT, and DBF, CDX, FPT. But for example, Visual Objects also had a combination of DBF, NTX, and FPT, which is called DBF Memo. We have decided to add two extra interfaces, iOrder and iMemo. And what the work area class does, it delegates all index-related or methods to a special object, which is the object that implements iOrder, and the same for all memo-related operations. It delegates that to the object that implements iMemo. And there are two base implementations of these, which do nothing. And these base implementations are base index and base memo. And a RDD that wants to implement a memo can inherit from base memo and then assign that to the memo field in the work area class. So a work area will then call the implementation of that memo class. And by doing that, we could fairly easily create variations of combinations of DBF and index and memo file format. And it also has as a result that you have a separate class in our runtime that handles memos. And if you look, we are inside that class, you don't have to worry where the memo addresses are coming from. It's just coming from a class from the outside, and you return it the data that it requests. So you have smaller classes with less functionality in there, which is usually a good idea if you want to create a system that's easy to maintain. Okay, so like I described, but now in an image, this green object here, the green rectangle, represents the collection of work areas or Foxpo data sessions. And what's important to realize is that X# is multi-threaded, and we give each thread its own work areas. So when you open a DBF or whatever, a table in a new thread, it will create a new work areas collection for that thread and add the tables in there. That means that tables in different threads can have the same alias and the same area number. These area numbers and aliases are saved per thread. And of course, if they want to read the same table, they need to open these tables in shared mode. Otherwise, it will be just like if you run two instances of the same application. Each object in the work area or each area basically points to an iRDD class. And these can be all of the same type. So if you set your default to CDX, DBF CDX, then they can all be implementations of iRDDs in the DBF CDX class, but you can also mix them, of course. This is a global overview of the classes that we have in X#, and it's quite a long list already. On the bottom, you see the work area class, and the work area class is not in X# RDD, the assembly, but it's in X# core. And the support methods, the support types like DB order info, etc., are also in X# core. The rest of what you see here is in X# RDD. On the left-hand side, you see the family of DBF things. So we have DBF, which is just the driver, no memos, no indexes. We have DBF BBT, and we have DBF NTX. And as you can see, these are created on top of each other. So the DBF BBT inherits the behavior from DBF, and NTX adds support for indexes. The sibling therefrom is DBF FPT, which is the memos. We have implemented flex file memos. So this is not 100% identical to FoxPro, but does a bit more. You can also store other value types in there. And on top of the FPT, we have CDX. And then on top of that, we also have two other ones. The DBF VFP, which is the visual FoxPro layer, which the most important difference between DBF CDX and VFP is that it's VFP supports more field types like integer, auto number, etc. And then we have derived from that a DBF VFP SQL, which you normally wouldn't use in your code. But if you open a table with SQL exec in the FoxPro dialect, it returns a cursor in memory. And this cursor is basically an object of DBF VFP SQL. And the biggest difference between the VFP SQL and the VFP is that the VFP SQL bases its rows on a .NET data table. So it's basically an RDD that is created on top of a data table. So that's why we have it in a separate class. And you can imagine that most of the logic is the same, but for example, where a normal DBF would read certain bytes out of the file, the DBF VFP SQL will read for the current row a column, a data column, and get the value from there. So it's the mechanism for reading and writing fields is of course different. And when you create a DBF VFP SQL, you need to give it an ADO data table. So that's where it gets its structure from, basically. In the middle, you see, which is now one block, but we have a whole bunch of ADS, Advanced Data Server RDDs. And on the right-hand side, we have a smaller family of text RDDs for reading and writing SDF file or DLIM. And we have created an extension to DLIM, which was the original Clipper format. And we added comma-separated values and tab-separated values as formats. And the biggest difference between the LIM and these other two formats is that these two formats have a header. So we're writing the header with the field names, which if you import something in CS3 into Excel, you would like to have a row with field names, and this takes care of that. That's basically a different way of seeing it. Okay, I'm almost done, and then we'll go to code. Each RDD, originally in the Clipper days and also in Visual days, had a file handle. And inside X we still have that. But the reality is that we don't actually use the file handle. We use stream objects. What we do inside the RDD system is we open a file with the normal fopen or fcreate functions. And once we get the file open, we actually ask the runtime which .NET file stream object is associated with this file handle. And from then on, we will work directly with the file handle and no longer with the file handle, we work with the stream. So that's why we do. And everything is important, is written in managed code, and it all runs in any CPU. I think the previous slide showed that. And there's one exception to it. If you run on Windows, we have discovered that the .NET file stream sometimes has problems and is sometimes a bit slow on Windows. And we created our own special file stream called Win32 file stream. And this directly calls into kernel 32. So by using that, We're still code against the file stream, so the DBF class itself doesn't know that it is a Win32 file stream, but that under the hood that is. And what we've done in X #210 is we added caching to the file stream and to the DBF system to make sure that the performance is good. And I think Karl-Heinz posted a GIF this week to give you an idea about speed comparisons, and we actually are in many areas now faster than, for example, visual objects, because we use caching, and that prevents us from reading the same record more than once. This cache, of course, will not grow indefinitely, so we have a setting which will mimic the set refresh setting that people from FoxPro know, and that is with the set refresh you can specify how long this cache will be maintained, or after which time it will be basically discarded and the data will be read again. By using the cache, we now read not one row at a time, but we read many rows at a time. So if you read row 1 and in the next line you read row 2, then row 2 is already in memory. And by doing that, we reduce the disk access, and that has proven to be the most critical part of the RDD system. So if there's a performance issue, or there was a performance issue, it was mostly due to the fact that we were reading too much. And by using the cache now, we reduce the number of disk IOs, and that has a result that things are much faster. On top of that, we've also added a new setting called set hard commit. And this setting, we got the idea from the people from Harbor, and this setting, which default is on, but controls if the RDD system should wait for a commit or a flush before continuing. The default is true, that means that it waits. If you switch it off, you can see that your program will probably run even a bit faster. So this set hard commit is by default on, which means that if we call flush, the application will indeed wait until the OS says, yes, it's done. But if you switch it off, it should continue and trust or hope or pray that the OS does what it promises to. If performance is a big thing for you, we recommend to try this and see if it causes problems in your code or not. We haven't seen problems, but we were a bit cautious, and we didn't want to make the default to not wait for the commit, because that's what was doing in before we were waiting, but now you have the option to switch that off and let your app continue. Now, of course, what could happen is that if your app crashes before the OS is done, you could lose data. But if your app crashes, you probably lose data anyway. So the question is if that is really a thing or not. Are there any questions so far? Okay, good. This was a slide, yeah. We have several advantage layers. We didn't invent all these names. These were the same names that the advantage RDDs in Clipper and Visual Objects were, and also for Vulkan, these names were used in the advantage DLL. In contrary to Vulkan, you do not need to link in a special advantage RDD in your app. The X RDD has all these classes in there. Of course, we do not include the H32 and the H64 DLLs and its support DLLs, because these are part of the advantage product itself. We cannot distribute those without asking for permission. But if you need advantage, make sure that you have advantage support DLLs in your app folder, and the ADS RDD calls into either H32 or H64, depending on if you're running in 32-bit or 64-bit mode. The advantage support functions and structures, for example, structures to ask who has a table open, etc., are also part of the X RDD assembly. So if you directly want to use these, or you directly want to use the ADS functions, you have to add a reference to X RDD in your code. Normally, you don't need a reference to the X RDD, but in this case, if you want to use these ADS functions and the ADS structures, you do have to add a reference to X RDD. Okay. Like I said at the beginning, I did a session in almost 2 years ago about RDD. What has changed since then? Well, most important change is that we enhance the performance in all DBF-based RDDs. This should really be noticeable if you use these RDDs, especially if you use them in shared mode. Because before, in exclusive mode, we were already doing some caching, but now we also cache in shared mode. And you don't have to worry that if you start writing things to a table, that you may be writing over old data, because the cache is smart enough when you start a write, so you basically want to lock the row, that it will actually fetch the current row from the underlying file, so you will not overwrite old values. So it's smart enough to take care of that. The other change that we did is that we now support nullable keys for VisualFox Pro, and VisualFox Pro can sort indexes based on collations, which is different from what the Visual Objects people will use. In Visual Objects, you would set a global collation information, like set collation clipper or set collation visual objects, and then you have one global sorting rule. Fox Pro can have different sorting rules for different tables in one app, and these are called collations. We support that now too. So when you open a table, it actually reads the collation name, and each time you seek, it uses that collation to transform your string or number into the right way. So it can find it, and if you update the index or update the table, it will use the collation rules to transform your strings into the bytes that need to go into the table in the index. And last but not least, we fixed several bugs. Some of our users had problems with running DBF CDX mostly in the network environment, and due some help from others, we were able to fix that problem in last December. So the current build to 10 should have no DBF CDX problems anymore. These are all fixed. There are still some areas for improvement, but that's another thing. So we still have some ideas, but for now, the basic DBF, CDX, and FPT is working as advertised. Okay, I want to briefly touch the RDD system in a macro compiler and then go to samples. Okay, we got some questions about RDDs and macro compiler, and I've tried to summarize in this slide how these two are related. And first of all, the RDD system sometimes needs to compile strings for index expressions, for filters, and to compile and evaluate DBL conditions. And to compile these expressions, we use the macro compiler. And the result of the macro compiler is something that's called a code block. We all know that. And in the RDD, you sometimes need to evaluate the code block. Now, we have added a compile and eval block method to iRDD and implemented those in the work area class. I'm going to show you that. And we recommend that you use these implementations in the work area class because they care of automatic switching between work areas when necessary. Let me show you that. On my screen, you see the work area class. Let's find compile. Over here, you see that there's some extra tricks involved, and I'm not going to bother you with all of that, but over here, what you see is that we get the macro compiler from the runtime state, and we compile the object, and this extra parameters we can ignore for now. And yeah, well, it tries to find a special type and in the end compile the code block. And we try to convert it to a special object called X _ code block, and well, it basically stores more than just a code block. The other one, this is the important one. If you evaluate a index condition or an index expression, it often contains things like last name plus first name, order number or customer number plus date to string order date. These names, of course, only have meaning when they are applied to the correct work area, to the correct cursor. Because if you have more than one table open, you want to make sure that the table where you're evaluating the code block in is actually the table that the code block was created for. And that's what this method does. It says, okay, if the current work area, which is we get here from the runtime state, is not the work area from this RDD, so each RDD knows in which area it's open, it'll switch the RDD, will switch the work area. So in this case, we are assigning the area number and then we evaluate the code block. So this makes sure that when the code block is evaluated, it actually can find last name or first name or order date. If you don't switch, you could be evaluating the code block in the wrong area. And finally, it restores the current work area. So this takes care of saving and restoring the work area. If the area is already the same, we don't do that. We just evaluate the block. And this actually, it looks fairly easy, just an assignment, but this is not a simple assignment. There's a property, and in the property, it not only assigns the number, but it also assigns an object and sets some other state. So by preventing the switching the state, we can actually improve performance. And over here, you also see some other tricks that's especially important for FoxPro people, because how do I explain it in a simple way? FoxPro doesn't know the nil type. All variables in FoxPro are initialized when they are empty with something that is called false. Now, if you evaluate the code block and the result was a nil, you don't want to return false, because many operations, for example, the DV eval, where you evaluate the code block for each row, it'll abort when the code block returns false. So even when the code block had no value for FoxPro, that would be seen as a false. And that was one of the bugs that the customer complained about, that this code block gets evaluated once and then the loop gets aborted. And we discovered that that was because the code block was actually returning nothing, and in FoxPro, nothing is false. So what we do now is, if the code block is of a special type, code block 2, which is an addition to the code block, we store the original result type, the void, which means nil. And if it was void, then we don't give it the value false, but we give it the value null, which will then make sure that loops are not aborted, etc. So if you would code this yourself, you would have to take care of this kind of ugliness yourself. So that's why we recommend use these methods in there. To give you an idea about some of the other methods that we implemented, let's see. You see skip takes care of skipping with filtering and skip roll. Skip filter takes care of the current filter information and the deleted flag. And so when you skip and you end up at a deleted row, it continues to skip to the next one. If you end up in a row and the filter evaluates to false, it will also continue to the next row. So these implementations in the work area are helpful because you don't have to worry about that in your own RDD. If you just implement a raw skipping, which is not implemented here, as you can see, then it will actually, this class layer will take care of the skipping. You see a skip scope, which skips with file and for conditions. You see, some of these are implemented. For example, actual appending or deleting is not in this work area level. But close, for example, is, and of course, this doesn't close the file because the work area has no idea whether there's a file, but it clears the filter, it clears relations, it clears the scopes, etc. And when there are parents, it actually tells the parents that this child is now closed, etc. So this takes care of a lot of things that you don't want to implement in all of the derived RDDs. Good. Now we have seen a bit of the RDD system. Let's look into event handling. And now I'm not going to go to the slides anymore. I'm going to show you the event handling code. We have added a mechanism to the RDD that allows you to register either a function or a method with the right parameters to the RDD system, and this will get called. Or what you can do is you can register a client object that implements the interface RDB notify. Now go to the main loop in this program. Over here, you see, let's do the method or function way. Now I'm having the function notify RDD operations, and this function has to have the proper prototype because it needs to implement the delegate that says there's going to be a sender as type IRDD, and of course it's going to be an argument as DB notify event args. And DB notify event args is an object that has data which is depending on which event it is. Could be like a string that has a file name or a field name, etc. And it has a type, and this type says it's a file created or a file opened or a field update, before update and after update, before move and after move, etc. So this delegate gets called each time one of these events occurs in the runtime. And if what this particular implementation of the delegate does is says if there's a sender, then I'm going to show alias, area, the type, the data, the VOF and the EOF to the deb out screen. So this is basically the debug window in Visual Studio. Or if you run it outside of Visual Studio, the output debug window that, for example, part of the system internals tool. Let's just run this sample and let's see what happens. So this is a standard MDI app, and I've told it that I have a notification handler. But when I open the table, you will see that I get a file open with the file name of the particular file that I've just opened. And then now I'm going to move. So I get the before move with the data says this is a skip. And I get an after move with skip. Now it's not passing the record number, but it's passing the object of the RDD. So this is an X RDD IRDD object, and in this case, it is the DBF NTX in object itself. And inside this object, of course, we can see the area number, we can see the field count, we can see actually we've added for debugging field values, which is a list of named value pairs. And you can get everything like the record number and the rec count is in here. So all that information is not passed as data, but since we're passing the RDD itself, it's there. So we did a skip before and after. Now, of course, if you go to browse view, you see before after move a lot of time. So I'm going to disable it for now because the browser actually skips to all the rows. Where's my sample here? Let's say I'm going to change Maria to Robert. Now I get a before field update with first name. And in the object, you could do a get value, which basically gets the value, or you could even do a field get. But if you look here, you will see first name is Maria. And now it comes back, and the type is now, can I see it here? No, not really, but the value, as you can see, is the new value, is the value Robert. So I type something, I tap to the next column, and as you can see, the data browser has written it to the table. Now, when would you use this? That's a question you may have, and I would say the most important one is you can use it for debugging, and maybe not the function-based, but let's go to the other example. If you do not register the event handler, you can also register a client. In this case, it's MyDB Notify, which is a class on its own, but you could also implement IDB Notify on your shell window if you want. That's up to you. Probably, I wouldn't recommend that, but it is possible. IDB Notify has only one method. It has the name notify. It has the same arguments as the delegate that we've seen before. And in this case, I have decided to add the VO compatible log file class, but in reality, of course, you would not use the VO log file, but you would probably use something like nlog or serilog or something like that. And this now writes information to a log file. And if I run the app again, you may wonder why Robert was back Maria, but that's because I have a copy action in my project that copies the file over again and again. So I start with a fresh file each time. Now, if you look in the folder where the app is, let me go there. You will see that I have now written, come on, why doesn't this work? Yeah. Event handler log, and you can see customer, that was the alias, the work area number, operation was file open, and it was the data. And over here, you can, for example, see that there's a field update. Actually, this is data from before. But this is the data from over here. This is the data from now, the file open. And because I changed the name, Maria, to Robert. And at the end, when I close the app, you see that there's a before bulk operation and after bulk operation. So when closing a table, it closes relations. Actually, in this case, there are no relations, but it still calls the method. And you can actually see that it gets called. Now, this was developed for a customer that was actually wanted to log when certain things were happening, because right now I'm only logging the operation, but you could also log the call stack. And if you have a complicated application, it may help you find where a certain value is written. So if you would set a, let's say, an alias, set a breakpoint depending on the alias and the record number, this can help you discover where exactly a certain value was updated, and you don't have to create your own RDD to do that. You could also create your own RDD, but this is cleaner because with one line of code you can enable or disable the logging. I can imagine that you could use something like this and have a menu option when customers report an issue that you allow them to log their operation into a file that they can send to you for support questions. Maybe in combination with the data file. So this event handling was added to help you debug problems in the RDD system. Has anyone used that already? No? No reply? You all have your mics off. Okay. There's an alternative way of seeing what happens in the RDD system, and that is by wrapping the RDD or by subclassing. But the first method that I want to show you is by wrapping the RDD. Inside the runtime, now I'm opening the wrong thing, I think. Oh, no, I'm doing the right thing. This, inside the runtime, we have added a special class called wrapper RDD. And what this wrapper RDD does, it takes a existing RDD and it basically delegates all the calls to that RDD. But it also has every method that an RDD needs to implement. Now, what you can do is inherit from this wrapper RDD. And for example, in this sample, I've played and I said all the calls to go top should actually do a go bottom. And all the calls to go bottom should do a go top. And I'm going to reverse the skip. I'm going to reverse the EOF and BOF. And when I do a get value and I find a name that starts with Todd, I'm going to return Robert. It's a bit, it looks a bit stupid, but it is what it is. So what I'm doing here is I'm opening the area, and then I'm using a special DBI constant to ask the area, what is your underlying RDD object? So this is the syntax to get the object that is behind an RDD. And what I'm then doing is, okay, I'm going to pass this RDD, I take that and I'm going to wrap it. And my RDD, which inherits from wrapper RDD, what you don't see here is when you pass it, when you create it like this, it's going to look in the list of open areas, and it's going to replace the object ORDD with the one that is wrapped. We'll show you that in the debugger, but this basically removes ORDD and puts a replacement RDD in there. And from then on, the go top does a go bottom, etc. So let's just show it. Because that's what I've done in the wrapper. So the code did. So now you see that the go top actually goes to record 20. I'm not using indexes here. And top Evans is now Robert Evans because I've intercepted the field check. Now let's look in the debugger a bit more. And let's go to this line. In this line, we have the area open. And I'm going to go, this is something you may want to write down until we have a work areas window. But if you do xr.runtimestate.work areas, you can see the collection of open work areas. If you open that, you see the current work area, which is customer based on dbf NTX. If you like this kind of data instead of the type name, we've used what's called a debugger display attribute on the class, which determines what you see in the debugger. And when I get the object, you now see that ORDD is indeed dbf NTX customer. But now I'm going to wrap it in this wrapper class. And what you see now is that ORDD, which is now a wrapped object, contains the original object. But in the runtime state, you also see that that object, which is also in this dictionary, is now replaced with the wrapped one. So the constructor of the wrapper RDD also inserts itself instead of the original RDD in the runtime state. And that's what's happening. And now basically the go top does what it has to do. This looks normal, but in fact, in reality, it's now reversing whatever the operations do. Now, where could this be useful? Again, you could use this if you want to add logging or some kind of tracing for one area and not for all the others. The event handlers are called for all the areas. So you could do this and use this mechanism. And of course, normally you wouldn't reverse the order of the rows this way, but you could use this mechanism to follow what's happening in a certain area. Again, this is not, you probably will not use this in production, but this is more an aid for debugging. You can basically every method in the RDD, even the methods that are not sent as events to the event handler, you can now monitor. And that's what I did. I did the get value, which is not monitored with DB in the DB RDD monitor code, basically, because getting is usually not really an issue, but by using the wrapper class, you can actually monitor what's read and play with that data. So I have a slide about this that I want to show. Okay, so what does it do? The wrapper wraps the methods, and you can override methods. It installs itself in the runtime state, and it works for all RDD types. So it works on top of dbf CDX, but also on Advantage or on the text RDD. It's relatively easy. One disadvantage is that there is no normal way to access protected fields and properties from the parent classes. To do that, you would have to basically inherit from RDD class. And that's what I want to show you in the next example, how you can inherit from a class and change the behavior of a class. So, and of course, you can also create a complete new RDD. Now, here are some options. You can choose to create a complete RDD from scratch and implement it directly. That's a lot of work. And you will have to think about, like what you saw in the work area, where are the macros evaluated? You can also inherit from work area, and you have some basic functionality, or you can inherit from complete RDD, so like dbf NTX or CDX, and change the behavior. Now, in my next example, I want to show you an RDD that does poor man's encryption. But of course, you can make that as complicated as you want. Okay. And by the way, the last line here says how you register a new RDD. There is a registered RDD class, which basically contains a list of all the names and the types. And to add your own type, you call the add method and give it an object of type registered RDD and with the name and the type. In this program, I'm going to open a custom RDD that I'm registering, and then I'm going to open a table with this RDD. And if you look into this registered custom RDD, it says exactly what we saw in the sample. I'm going to register my DBF NTX. Its type is my DBF NTX, and I'm going to set the default RDD to my DBF NTX. That means that if you do not specify an RDD, this will open. Now, what is this thing doing? It is actually taking a table, opening it with the normal open method, as you can see over here, and then it's going to encrypt all the rows in this table where necessary, when they're not encrypted yet. Now, normally you wouldn't do that like this, because this now goes through all the records each time you open the file, but I'm doing this for this sample because I'm starting with a customer DBF over here that is normal, not encrypted, but of course I want to have it, why is it doing it twice? I want to have it encrypted. Now, what does this encrypt do? Basically, I have a property here, encrypted, that says if the record buffer, so I'm assuming you know how DBF looks, but a DBF consists of, let's say the record is, all the columns together have 50 characters, then each record is 51 characters long, and the first byte in that is either a space or an asterisk indicating non-deleted or asterisk for deleted. Now I'm using that information so that the first byte is either 32 or the asterisk, which is, I don't know the number, is 42. If it's 32 or 42, then we know that it is not encrypted. And if it's not one of those two values, then we assume it's encrypted. Now, in the RDD, I've overwritten a protected method. That's why I needed to do this in a subclass. The method is called read record, and it's a method that's implemented in the DBF type. So what I'm doing, I'm reading the super read record. I have no idea what it does, but by studying the RDD source code on GitHub or by looking at it with ILSpy, I figured out that it fills the protected field record buffer with bytes. So what I'm doing is say, okay, if the first byte, this is what this checks, indicates space or asterisk, then it's not encrypted. So, but if it is encrypted, I want to decrypt it. Now, this is a really poor man's encryption decryption algorithm because I'm shifting each byte in the buffer. So if the buffer is 0, I'm going to make it 255, and otherwise I'm going to decrement it to decrypt it. And if when writing, then I'm accessing a property which says hot. It means something was changed. And I know that super write record is not going to write when hot is false. And then when it's hot, I'm going to go to the buffer and increment each field with each byte with 1. And then in the end, I'm going to call super write record, which will then write this updated set of bytes to disk. Now, these methods, go hot and go cold and get value, are in there but are actually not used or not necessary. Now, how does this work in the sample? I'm just opening the table, and then let's set a breakpoint in the open method. Okay, I'm in the open method. Now I'm going to call super open. It's successful. Now I have a memory debug window in Visual Studio, and I've told it to display. This is a bit, this is still C# syntax. I'm sorry, we're working on a X-based syntax expression evaluator, but this is now C#. The address of record buffer 0, which is basically show me the content of the record buffer. You could also try to do this, but then we see here the address of the buffer, and I don't want to see the address, I want to see the content of it. So that's why I use this syntax. So now I do the files open, I do a read record, and suddenly you see here that this now contains the data that was read from the file. And the first byte is 20, which is hex 20, so it's 32. It's not encrypted. So when it's not encrypted, I make it hot, and then I'm going to call write record. And it says if it's 255, it's not, then it's going to change it and increment it with 1. So now hex 20 has become 21. And I'm not going to bore you with everything. In the end, you will see that this now gets encrypted. So this is now the current buffer. And of course, if we iterate through this, you will see that all records are encrypted. Now, it suggests that we check in the low-level file viewer. This will do. As you can see, this is now an encrypted DBF. So if you look in hex mode, you will see that the header is still fairly normal, but from the first record on, everything is encrypted. Now, no hacker would really be impressed by this algorithm, because they would soon enough figure out that all the exclamation marks are probably spaces, and then discover that we've incremented everything with 1. But if you do a better encryption algorithm, this should work. Now I'm opening it again, and now I have a problem. I have something wrong in my algorithm. And this is not what I wanted to show you. This is not doing what I hoped. As you can see, coding is sometimes difficult. Okay, let's go to the other sample where I know it worked. This has the same custom RDD. But I know I've played with this one, and then this works fine. It started for the no, it doesn't. As you can see, the first field is corrected. I've made an error. Sorry about that. The rest is decrypted properly. It's also written properly, but there's something wrong with the first column. That's what we saw before too, as well. So I'm doing something not right. I have no idea why, but you get the idea that you can inherit from an existing RDD and then do things. Maybe This logic is wrong. This is okay now. Hopefully it's not cool. Okay. Read record is called before by open returns. That's interesting. That makes sense, of course, because opening a table is going to read the first record. No, forget about it. I'll post a fixed version, a sample on the website. This should have worked, but I've probably done something stupid. Okay. Final thing that I wanted to show or talk about is about multi-threading. I've mentioned before that each thread has its own runtime state and has its own work areas. Now let me open a file. This is the X runtime state class. This class takes care of all your settings, but also has information about which work areas there are. There's this one. You can see that there's a property, if I can find it. I can't find this. List of properties is too long here. And over here, we have a work areas property. So the runtime state has a collection of areas. And there's a static property data session or work area, which is basically the same. And there's also stuff in here that's, for example, used if you have an alias expression. You want to, when you enter, after the arrow, basically, you want to push the kernel work area because you're switching, you want to pop. This is also handled inside the runtime state. And inside the runtime state, you find also stuff like the current sort order, the collation table, or the current macro compiler. Now, if you run more than one thread, this runtime state gets copied. Each thread gets its own copy. That means that if you have a separate thread that sets, for example, set deleted or set soft seek, that's not going to change the set deleted or the set soft seek in the other threads, because these values are stored in the runtime state. However, and what it also means, each runtime, each thread gets its own set of work areas. Now let's go at a sample program and let's set a breakpoint in the constructor here. Static constructor. And so this is a sample program, and I should give credits to Chris. Chris wrote this. I've adjusted a bit for today, but this sample program is creating 10 threads. And each thread has a method which is called test, and the test method is going to do a couple of iterations, and depending on the value, it's going to append a row, or it's going to go to a row and update it. And the sample uses dbf cdx. There's an index on the column that gets updated, so this really trashes a lot of data. And Chris wrote this because we had a problem, but it's also now a nice sample of several threads running side by side. Now let's run this first, and then, okay, this is the wrong one.
Alle miteinander.
As you can see,
Nein, schnell so, immer mit auch ganz schnell.
you can see that each thread is writing to the window, and when we scroll back, you can see that I was testing 10,000 iterations, and you see the first thread with 1,000, the second thread 2,000, and actually before thread 2 has had 1,000, thread 1 has already had 2,000. And you see the thread 3, it gets before thread 2. You have no control of that, that's not the thread. And each thread reaches 10,000, and in the end, this is what Chris added, some check to see whether the resulting dbf and index are okay. So each thread opens the same table. Now let's see what happens if we open the table in the thread. This one didn't get closed. First, we appear here, and we look at the call step. We come here from app init, which is a compiler generated startup method, which initializes the runtime. And then the first main thread is created. Now we're in a thread. And in Visual Studio, you can actually see that with the debug Windows threads. You can actually see that we're now in work a thread with the name thread 1, which is what I assigned, and its managed ID is 3. So, and what happens if I do a debug use area? Actually, the debugger is already too slow because other threads were open, but now we are again in thread 1. And you can see that now a new runtime state object gets initialized. So this new object, this new runtime state gets a new collection of settings, and this collection is copied. Let's look at it over here. Okay, over here you see that it copies basically all the values over from the main thread into the new thread. Now it's a bit of work, but and then in this object, this you see now this is the main and on new is number 3. It will then register the work areas, data session. At this moment, there's no data session yet, but if we go to debug use area, no. Now we see you see that there are also not just 10 threads with 10 areas, but you can also see that there are different data sessions for each thread. So there's a data session with the tables for thread 3, 8, 4, 2. These are in random order. from looking at it, I think that thread 5 isn't even there yet, so it's not ready yet to open a table. But if we now we see thread 5 also has a data session, and in the end, basically, all of them will have a data session. Now each of them has a data session, and things are just zooming and working as you would expect. Now the output on the console is a bit distorted because using the console for output in a multi-threaded app is usually not a good idea. And the fact that the debugger is running now sort of also stops basically the process. The debugger itself interferes with the threading, but as you can see, if you run it without debugger, it runs smoothly. And well, you have no idea which thread gets called why, but Windows takes care of that, but it runs basically. So what I'd like to show you with this is that you can do multi-threading. You have to open tables shared if you want to share them with other threads, and they get their own state and their own information, and it works nicely side by side. Okay. Those were the samples that I prepared for the RDD system. If you want to see the source, go to this repo, GitHub, the X public repo. There's a Git link on the X website, and go to the public, and then in the runtime folder, you will find all the source.